Gibbs phase rule. According to this rule, degree of freedom will be equals to number of component minus number of phases present in the system at equilibrium plus 2 stands for temperature and pressure are two parameters. Now let us consider a binary system where A and B assumed to be two components. Here are the two different melting temperatures. This will be vapor phase, this will be liquid phase, and this will be vapor plus liquid combined phase exist. This is the liquidus line, this is the vapor liquid equilibrium line. Now what happens if we calculate phase here and here, the degree of freedom, the vapor phase will be equals to, in this zone, number of component 2, number of phases in equilibrium 1 plus these two reduced to be 1 as pressure remains to be 1 atmosphere pressure throughout the system. What happens? Degree of freedom will be equals to 2. But in the vapor liquid coexist zone, what happens? The number of components remains the same. Number of phase in equilibrium will increase from 1 to 2 and this will be 1. So degree of freedom reduced from 2 to 1. Now what happens when an intermediate phase generates? Supposed to be curved like this. I have shown here one maxima, it can be minima also. For the binary system A and B, let us assume the intermediate phase will be X. Now the liquidus line in the zone and the liquidus line in the other zone will be like this: liquid, liquid plus vapor, liquid plus vapor, and this will be the vapor zone. So if we calculate degree of freedom for this zone will be equals to number of component 2, number of phase in equilibrium will increase from 2 to 3 due to generation of this intermediate phase. 3 plus 1, which is equals to 0. This can be given the similar result to that of triple point, where pressure, temperature, three phase coexist: solid, liquid, vapor. It is the triple point. If we calculate the degree of freedom at the triple point, the number of component here is 1, number of phase are 3 in equilibrium, plus 2 is the two variant temperature and pressure. So the resultant degree of freedom will be equals to 0.